Today we're going to cover 8.1, graphing f of x, so a function when we were just dealing with ax squared. So I want to talk a little bit about quadratic functions. So quadratic function is a nonlinear function that can be written like this, where a does not equal 0. Now today we're only going to be dealing with that first term, and what we're going to be using is a parabola. Now, when we talk about a parabola, the minimum here is what we call the vertex. The axis of symmetry is where it splits it in half. And as you see, as we're approaching, as we read from left to right, and that's how we're also going to read a parabola. So as we're approaching 0 here, it's decreasing. As we're approaching positive, it is increasing. So let's talk about our first example here. Identify the characteristics of the graphing function and its graph. First of all, let's talk about the vertex. So our vertex here is at 2, -4. So that's our x and our y value. Our axis of symmetry is where it splits it evenly in half. So our axis of symmetry here is x equals 2. The domain is the x. So what could x be? In this case, x can be anything we want it to be. So that means all real numbers. Well, if x can be anything, what's our range? What could the y be? Well, if I look, the y can be anything from here up. So our range would be y is greater than or equal to -4. Now, let's talk about this parabola. So remember, here it's decreasing and here it's increasing. So as it's approaching 2, y increases as x decreases. So when x is less than 2, y increases so y is increasing as x decreases. When x is greater than 2, so here, x is greater than 2, as x increases, our y increases as well. So y increases as x increases. All right, so your turn. Go ahead and try these two. Hit pause. And when you're done, turn it back on for the answers. So now let's take a look at our next learning target. We will graph and use a quadratic function in the form of f of x equals ax squared. In our previous examples, we just dealt with x squared. Now we're going to take a look at a coefficient, which means we are going to end up with a stretch or a shrink depending on our coefficient. So let's take a look at our second example. So graph g of x when g of x equals 4x squared. Compare the graph to x squared. So the first thing we're going to do is graph f of x. We always want to graph 4 points, or 5 points, I'm sorry. And so here we have f of x equals x squared. Next, let's make a table of values. So if x is -2, g of x is 16. If x is -1, g of x is 4. We have 0, 4, and 16. So now let's plot these ordered pairs. So in this case, I now have 0, 0. I have 2, 16, 1, 4, -1, 4, and -2, 16. So here is my new graph. Whoops. Okay, so now let's take a look. So we plot the ordered pairs, we drew a smooth curve, now let's compare. So let's see. Both graphs have the same vertex, 0, 0. The axis of symmetry is also the same, where x equals 0. The graph of G is a vertical stretch by a factor of 4 of the graph of F. Now, let's take a look at how we can do this using Desmos. To graph these, we're going to go to desmos.com/calculator. Here, for one, I always want to put the parent function. This gives me something to compare our other function to. So I've got y equals x squared as our parent function. And then our new function is y equals -2/9 x squared. So now I can compare my two functions. So you can see our parent function. And if I want to look for points along the line, I can click on and just kind of drag my cursor around to find points. So I've got -3, 2, -3, -2. So I know that my other point will also be 3, -2. So I can use this as a guide to graph these functions on my own paper. Using what we did through Desmos, let's go ahead and graph our functions. So we've got our standard f of x equals x squared. We ended up with the same vertex, and then we had points -3, -2. Then we had points 3, 2. Drew our rounded curves. So this is h of x equals -2/9 x squared. So what do we know? Both graphs have the same vertex, which is 0, 0. The axis of symmetry is x equals 0. The graph of h is a vertical stretch of 2/9. The graph of h opens down and is wider than f. So we want to make sure we include all important information there. Okay. Go ahead and hit pause. It is now your turn. Yes, you may use Desmos, but you must also graph these on paper. So go ahead and hit pause and go ahead and start. Okay, so we can take a look now at your turn. So you can see the difference between number 1, h of x and 3/2 x squared. Same vertex, same axis of symmetry, but it is a stretch of 3/2 of f. Then if we take a look at number 2, p of x equals -3x squared. So same vertex, same axis of symmetry. It is now a vertical stretch by a factor of 3, and the graph opens downward and is narrower. Let's take a look here at our last example. It says the diagram shows the cross section of a parabolic mirror where x and y are measured in feet. So this is 2 feet, 4 feet, 2 feet, 4 feet. Find the width and the height. So if we take a look, the distance from here to here is 4 feet. Here to here is also 4 feet. So the mirror has a width of 8 feet, 4 plus 4, and a height of, let's see, from here to here, so that's 2, so that means that's 1, of 1 foot. Nice job. Go ahead and get started on today's assignment.